Hello, this is a little bit of a challenging lesson, so it's got kind of two I can statements here. I can find k in a polynomial equation given a factor or zero by substituting for x and p of x. And I can then solve a polynomial equation given a factor by dividing by the factor using synthetic division and factoring further. So this is like a 4-point question on the regions right here. It's got some challenges both conceptually and computationally, but this is an Algebra 2 question. Also, the first component of this question is also a very common SAT question. So let's get right into it. Considering the polynomial, blah, 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 find a value of k so that x plus 1 is a factor. So, this is the first conceptual thing you need to understand. We had a lesson earlier this unit called factors and zeros. If you know the factors, you know the zeros. If x plus 1 is a factor, that means that negative 1 is a zero. If negative 1 is a zero, that means that the point negative 1, 0 is on the graph. Now that I know a point that's on the graph, I'm going to replace negative 1 for x and 0 for y, or p of x. So p of x is 0, and I'm replacing the x's with negative 1's. Now I need to do algebra to find k. So negative 1 cubed is negative 1. Negative 1 squared is 1. Combine like terms. Negative 1 and negative 1 and 6 is positive 4. I finish solving for k. K equals negative 4. So that's the answer to the first part of my question. And my equation now is p of x equals x cubed plus kx squared plus, I'm sorry, not plus kx squared, I just fixed that. Let's just redo this part. So I have p of x equals x cubed minus 4x squared plus x plus 6. So that's the first part of the question. Let's go green for the next part of the question. Now it wants me to find all the zeros. So to find the zeros algebraically, I'm setting the equation equal to 0. Now normally I would say to factor this, however this thing doesn't factor. But since I know that x plus 1 is a factor, what I need to do is I need to divide that factor out. How do I divide? Synthetic division. I'm dividing by x plus 1, so negative 1 goes outside. 1 comes down. 1 and negative 1 is negative 1. Add them, negative 5. Multiply, add, multiply, add. Because it's a factor, I know that the remainder has to be 0. So if your remainder is not 0, then you did something wrong. So the polynomial becomes x plus 1 times x squared minus 5x plus 6. I'm dividing out the factor that I know is a factor because it told me. Now I factor further. Get the trinomial. X and x, first sign comes down, negative and a positive is a negative. What multiplies to 6 and adds to 5? 3 and 2. Now that I know the factors, I know the zeros. X equals negative 1, x equals 3, x equals 2. So it's kind of a long problem, and it is tricky both conceptually and computationally. So let's just run through it one more time. First off, if x plus 1 is a factor, then I know that negative 1 is a 0. If negative 1 is a 0, then I know the point negative 1 comma 0 is on the graph. So I'm going to replace the x's with negative 1's and the p of x with 0. I solve that equation for k. I get negative 4. So now I'm rewriting the original equation, and I'm replacing the k with negative 4. That's the first part of the question. Now to find the zeros, I set the equation equal to 0. I want to factor it, but I can't because it doesn't factor. But since I know that x plus 1 is a factor, I'm dividing that factor out. I use synthetic division in order to do that. The remainder will always be 0 since I knew that it was a factor. It must divide evenly. When I do that, I ended up with x squared minus 5x plus 6, so I wrote it as x plus 1 times x squared minus 5x plus 6. I then factored further, and once I had my factors, I had my zeros. Let's try another example. Consider the polynomial, blah, blah, blah. Find the value of k so that x plus 3 is a factor. Well, if x plus 3 is a factor, then negative 3 is a 0. And if negative 3 is a 0, then the point negative 3 comma 0 is on the graph. So I'm going to replace p of x with 0, and I'm going to replace the x's with negative 3's. I'll give you a minute or so to solve that equation for k. I get k to be negative 19. So my equation is p of x equals x cubed minus 19x minus 30. Now, I want to find the zeros. So I'm going to do 0 equals x cubed minus 19x minus 30. Since I know that x plus 3 is a factor, I can divide that out using synthetic division. List the coefficients. Since there's no x squared term, I have to put a 0 there. Outside is going to be negative 3. I'm going to give you about a minute to do the synthetic division. Again, try the synthetic division on your own right now. If you need more time, pause it. First number comes down, multiply, add. Multiply, add, multiply, add. The remainder should always be 0 when you do this because I know that it's a factor. So I end up with x plus 3 times x squared minus 3x minus 10 equals 0. Now we factor further and set each factor equal to 0. Why don't you take a minute, minute and a half, and try and finish this off. Factor further, set each factor equal to 0. If you need more time, you can pause it. It's a trinomial. x and x. First sign comes down. Negative and a negative is a positive. What multiplies to 10 subtracts to 3, 5, and 2. Once I have my factors, I have my zeros. X equals negative 3, x equals 5, x equals negative 2. So let's just go through that one more time. Because x plus 3 is a factor, that means that negative 3 must be a 0. So negative 3 comma 0 is a point on the graph. So I'm replacing the x's with negative 3's and the y's for zeros. And I'm then solving that equation for k. That gives me my original function. I'm replacing k with negative 19. To find the zeros, I set it equal to 0. And because I can't factor that, I know that x plus 3 is a factor, so I'm dividing that factor out using synthetic division. Once I end up with that, I factor further, and I set each factor equal to 0. It's long. Again, it's got some computational and conceptual challenges to it, but it's procedural. They're all pretty much the same. One little twist on number 3, it's telling you that p of negative 4 is 0. Well, if that means that negative 4 is a 0, which means that x plus 4 is a factor. So you're kind of just using reverse logic for this one compared to the other one. And what I want you to do right now is I want you to try number 3 on your own. I'm not going to give you time, so just pause it. And I'm going to go over it right now. So if p of negative 4 equals 0, that means that negative 4 comma 0 is on the graph. So x is negative 4, y is 0. So I'm replacing p of x with 0. I'm replacing x with negative 4. And I'm going to totally run out of space here. So let's see what I can do about that. Yeah, that worked out nicely. Plus k times negative 4 minus 12. We use our calculator if we need to. In fact, I need to maybe negative 256, I think. I don't want to mess this up. I'll use my calculator to be sure. Yep, nope, I was wrong. Negative 384. Negative 4 squared is 16. 31 times 16 is 496. K times negative 4 is negative 4k minus 12. Combine like terms. I'm just using my calculator to do that because that's the way I roll. I got 100 minus 4k. Subtract 100. Negative 100 equals negative 4k. K is 25. So that's the first answer to the question. Now that I have that, my equation is 6x cubed plus 31x squared plus 25x minus 12. So now to find the zeros, I'm replacing p of x with 0. And since I know that x plus 4 is a factor, I'm dividing by x plus 4. So I'm going to get 6, 31, 25, negative 12. Negative 4 goes outside, the opposite of what I'm dividing by. Multiply, add. So I'm just doing my synthetic division. It's going to always work out where you have a remainder since I knew that it was a factor. So I have 0 equals x plus 4. times 6x squared plus 7x minus 3. Now I factor further. I'm going to have to use bridge method here. X squared plus 7x minus 18. And again, some of you use the other method that we talked about, the grouping method. I'm going to totally run out of space here. So I have x plus 3 over 2, x minus 1 over 3. Denominator comes in front, and again, this is just bridge method. 2x plus 3, 3x minus 1, x plus 4 equals 0. Now I set each factor equal to 0. These are not super simple ones, so I'm going to actually go through that process. X plus 4 equals 0. 2x plus 3 equals 0. And then 3x minus 1 equals 0. So the algebra on this one was a little bit nastier because of bridge method. Subtract 3, 2x equals negative 3, x equals negative 3 over 2, plus 1, 3x equals 1 over 3, x equals 1 over 3. So it's a little hard to fit it all on one screen, but we found a way. So again, I'll talk my way through it one last time. Because that p of negative 4 is 0, that means that negative 4 is a 0, which means that x plus 4 is a factor. So if negative 4 is a 0, that means that the point negative 4, 0 is on the graph. So I replaced p of x with 0 and x with negative 4. I solved for k, I got 25. I subbed it in, that gave me this equation. From there, since negative 4 is a 0, I know that x plus 4 is a factor, so I divide that factor out using synthetic division. I get this. I factor further. It was bridge method, so that's why it got a little nastier. And then I set each factor equal to 0, and I got 1/3, negative 3 halves, negative 4. I think on my key, this problem is probably a little bit neater, but it is what it is. So, again, we talked our way through it. It's kind of a long procedure, and it's a little tricky both computationally and conceptually, but if you practice it and you have all the prerequisites, you should be able to do it. Your classwork/homework is to finish, and that's all I got for you. Have a great day.